We'll turn now to our next presentation. Those who may have attended day one of the Research Symposium will recall there was a presentation by Whittlesea and Hume Councils on the Upper Merri Creek Integrated Water Management Plan and how the councils had worked with traditional owners and the community more broadly to understand the aspirations for water management and to jointly undertake water planning for culturally significant sites. It was an incredibly interesting presentation, very innovative, and I encourage anyone who wasn't able to join us on day one or day two, please make use of the platform and you're welcome to have a look at those presentations. They're being made available online. But today we head to South Australia and we welcome Melissa Bradley, and she'll speak to us about a different aspect of integrated water management, another area that I'm particularly passionate about. And this is the evolution of infrastructure and water-sensitive urban design generally. Melissa is Program Manager for Water Sensitive South Australia. Water Sensitive South Australia helps government, industry and community to mainstream water-sensitive urban design and integrated water management practices that enhance wellbeing and ecological health. Melissa's role has a key focus on communicating the evidence base for water-sensitive city transitions and providing the tools, the guidelines and training needs by industry to apply this knowledge. So Melissa's presentation is Innovation and Capacity Building in Water-Sensitive Urban Design. Welcome, Melissa, and please start your presentation now.
Thanks. So just today I join you from the traditional lands of the Permeability people in Adelaide Hills. It's where I'm based, and I'd like to just acknowledge and pay respects to their deep spiritual connection and relationship to country. I'm glad you mentioned day one of the forum, because you're right, there was all these sort of high-level integrated water management planning strategies, and so now I'm going to show you today how innovative practitioners and consultants are being and sort of delivering those visions on the ground. So I'm going to sort of cover three main areas and three main challenges that we're facing. One of them is underperforming asphalt, and that's a term I borrowed from a TED talk. And that's all about increasing our permeability of our communities and our infrastructure and really turning sort of our grey infrastructure green. The other one is streetscapes. There's such a contested space. They have to do so much for walkability and amenity for our communities. But if we really want canopy, which seems to be the big thing now with urban heat being a main factor in our cities and communities, we need space, we need soils, and we need water. So I'm going to show some solutions for that. And then we also have lots of multiple needs from our open space. And the only way we're going to meet all those multiple needs is if we take an integrated design approach. So I'm going to show a few examples of that. Okay, so the first one is this idea of increased permeability of our grey infrastructure. So this example that I have here is for Kegworth Road in Melrose Park in the city of Mitcham. This project came from the issue that council was having 3 or 4 times a year. Council was having flooding of this street that was kind of topping the curb, and they were facing a sorry, I'm not sure why that's that. They were facing a $1.2 million cost of a trunk main upgrade, and if they were going to do a conventional approach. But what they did was they did a combination of 2 intersections with permeable paving in combination with infiltration systems in the park that you can see in the background of that photo, to basically manage the same level of storms that they were trying to manage with their trunk main upgrade. So I'll take you through what that looked like. This is a plan view of that intersection. The view you were seeing before was from top of screen looking into this car park. The area that I think you can hopefully see with my mouse below is the park. And what the system does is that it manages the excess stormwater runoff stormwater runoff will infiltrate through the permeable pavers in an uncompacted subgrade. The excess will run off through the side entry pits and into the park, and they'll be distributed through a network of 110 metres long of infiltration trenches that are shown in that light blue on the drawing. and they're ranging at a depth, invert level depth of about 600 mil to 100 mil below the park surface. And sort of what that looks like, those infiltration trenches, is just a typical, it's a 225 millimeter slotted pipe surrounded by no fines, so no fines aggregate, and then surrounded by geofabric. It's a very simple system, yet so effective at taking the stormwater, managing those peak flows and the volumes. And I want to keep reiterating, it's not only about peak flows that we want to manage these days, it's the total volume. And the system does also have underneath the permeable paved surface a couple of large vertical wells that connect additional overflow to a limestone layer about 2 meters below the surface as well. So there are a couple of mechanisms to intervene and intercept the stormwater before it runs right into the trunk main, which goes down South Road, which is one of the major roads in South Australia. So now that water, instead of just rushing straight out to the coast, is now keeping those trees those old gums in that tree, in that park, very healthy, and they've never been healthier. So in terms of the cost, I mentioned that council were looking at that trunk main upgrade. It cost them about $30,000 more to do the permeable paving in the intersections rather than doing a typical asphalt surface. But again, overall, that's in comparison to a $1.2 million trunk upgrade. So they've saved themselves, virtually $1 million in the process. So I think the common barrier to water-sensitive urban design is often a pushback around cost. But if we look at a place-based solution, as the speaker before me was mentioning, in this case, water-sensitive urban design was the most cost-effective solution. So we really need to take everything in terms of its context. And just for the people who love research stats, we know that there's been studies that in some catchments you've been able to manage 67% of all rainfall events less than 50 millimetres just by permeable paving alone. So that means if we put it in, the majority of events won't even end up reaching the wider drainage system. And I've got some references that I can share afterwards as well. Another project that was done by in the St Mary's car park, and they looked at a crumb rubber porous asphalt, and this is a trial whereby council have put 50% of the pavement is made of recycled tyres. It's been done with Melbourne Uni, and in this innovative trial, what they've done is made a porous asphalt that is taking the water from their park to the car park to the nearby landscaping. And the idea is to improve the health of the garden, groundwater recharge, improve surface runoff, and reduce the risk of flash flooding. So they prepared the site in a normal way. They have under drainage, as you would have with a permeable paver. Because it's not a compacted base, they have a stabiliser within the material to keep that structural strength. And what they've done is they've created a series, they've backfilled with gravel over the stabilising structural material. But then what they've done is they're monitoring the quality of the water passing through the system and the efficiency of the design in removing contaminants and water quality issues. In this image that you can see here, at a sort of a launch event, they tipped about 3,000 litres of water onto the site. This is your typical permeable paver that you saw in the previous example in Kegworth. This is a porous paver with a dark stone, and then there was a porous crumb rubber pavement with a lighter stone. The researchers are also measuring the heat from each of these different three surfaces to see which type of surface is also contributing more to the urban heat island effect. You'll also see that the water didn't really make it past the middle of the car parking bay on its way to the low point here, which is the curb and gutter. So again, a lot of the water is going to end up reintegrating back into the environment and maintaining the local landscape and the landscaped areas. The next one I want to talk about is car parks. They're easy wins. Oops, sorry. So car parks have minimal conflict with underground surfaces. They're such a large area. There's very rarely, underground cables, etc. It's because of the space, they can be run elsewhere. So it's not a contested space like a streetscape. It is so easy to achieve water-sensitive urban design. So really, there's absolutely no excuse for not doing in these contexts. So every time we don't do water-sensitive urban design in a car park, we're forcing that water onto a recreational park somewhere downstream and taking away from its amenity. So let's deal with the water where it falls. So the way that we can achieve that is making sure that we've got the right project briefs that really dictate that we want integrated water and landscape solutions in our car parks and performance measures around stormwater runoff quality, volume and peak flow management. And that's going to generate better design. So this is Adelaide Oval, Fig Plaza. The car park drains to this central landscaped area. If you can see just here, this little circle here, it's all of these bedding bays are connected via openings. So when it starts to fill, the water spills and fills evenly throughout the space, the garden bed. As you can see, the finished product, there's permeable paving between each of the tree planting areas, and there's openings for the stormwater to run into the bed. Those permeable pavers are there to help the aeration of the soil, to help the plant growth. This photo was taken in 2016. And the next photo you'll see was taken in 2018. So the growth in just 2 years of these trees has been phenomenal. And a lot of that will be to do with having this regular top up of stormwater and storage. Just wanted to let you know too, those garden beds were free flowing. They weren't lined. They were connected to the natural ground surface. You've also got streetscapes, this contested space I spoke about. We've got this big rollout of tree plantings to address urban heat. But if we don't bring water back into those trees, we're not going to get the survival rates and the canopy potential that we're looking for. So this development is Lightsview. It has a recycled water, stormwater from Salisbury Water into this development, into another council area actually. And you can see the tree that was planted, that's May 2015 from Google Maps, Google Earth. Only 18 months later, it's had this growth. These trees are maintained by the stormwater that goes to the householder. This is the only tree that they have. They don't have any space growing land, and they water the tree. So they're responsible for watering it with that recycled water that's plumbed to their front yard. So people will, participate in urban greening in the Verge if they, I suppose, have a really good sustainable supply. We also have tree net inlets that are very common throughout South Australia, and having tree pits with leaky wells. And this is another way, taking that top off the hydrograph and getting the water, reintegrating it back into the environment and having it benefit the local trees. Very simple, only costs about $500 per inlet if you're doing them in a bulk run. And we just, these trees are going to have so much better growth. And the councils are starting to gather the evidence around health. And there's lots of actually controlled trials here in South Australia at the moment where people are putting tree netlets in with similar trees and having controls. And soon we're going to be able to provide the evidence of how these inlets are affecting canopy cover. And then just finally, this idea of integrated design. This one will be familiar to some of your members. This is a Newnham development in Mount Barker, one of the NGAA's members. Mount Barker is about 38 kilometres from the Adelaide CBD. This development's on the current outskirts of Mount Barker. It has high amenity with the Western Flat Creek running through it. This is what it looked like when I was there last week. It is beautiful, and the development is coexisting with this natural environment. There's going to be about over 700 allotments on 130 acres. It was formerly farming land. You can still see the adjacent part is still farming land. If a conventional design was applied to this site, there is no way that this amenity would be maintained. It would only be a matter of time before these natural values would have been degraded. And I just wanted to reiterate, detention basins alone are not enough to maintain natural systems and natural creek systems in urban environments. We need to reintegrate the water back into the environment throughout the urbanised catchment for all the water quality, watercourse integrity and urban cooling benefits that it brings. And so we need to manage the volume and frequency of flows to the creek, not just detain the peak flows and let them out slowly. This hasn't really caught on, and I commend Burke Urban and the designers, Wallbridge and Gilbert Aztec, because this is absolutely innovative. What they've done, they've got a series of large wetlands proposed up catchment, but the ones that I'm going to show you now are these what they're calling ecological sponges that are along the watercourse proper, and they are delivering this idea of slowing down the water, infiltrating it into the ground that contributes to base flow. So I'll show you what they look like. So this is the ecological sponge. It's right next to the main boulevard coming into the development, and just to the right is the Western Flat Creek proper. And so what they've done is this design is, instead of having a direct discharge from the stormwater drain into the creek, it must flow through this ecological sponge, which also has infiltration storage underneath, and then the water will slowly seep underground and then create base flow, which is like the base flow into the creek, and it'll absolutely slow it down to a rate that the creek won't be adversely impacted. And then, oops, I've missed one. And then they also have those verge inlets that I spoke about, that the train net inlet. Every household has one of those outside of their house. So the developer has looked at things within the streetscape they can do to slow down the water and integrate it, and they're doing it right in the open spaces. But the result will be, I think we'll be able to come back in 10 years' time and look at Western Flat Creek, and it will not be adversely impacted and eroded like the majority of urban streams are in growth areas and in more developed areas. So I hope those examples have been useful.
Thanks so much, Melissa. And I'm just looking at those beautiful pictures. It's just amazing to see so much green in the landscape, and the fact that the developers, whether it's required or by virtue of them wanting to do the right thing, are really thinking about keeping water in the landscape is fantastic. It's something that I think in the growth areas we can really start to push the boundaries with some of this, with this technology and with the objectives, and actually really make the feel of these communities very different to sort of inner and middle ring, and that is really what will define the sense of place for these communities, that they are green and cool. I think there'll be some questions for you also in the panel just around that. And I'm looking forward to hearing those and hearing a little bit more about that work. But thank you very much for your presentation. It was fantastic.